All right, so what we're going to be looking at today is section 6.6. What section 6. Or I'm sorry, not 6.6, 6.1, and what that is going to cover is we are going to be looking at the difference between net versus gross displacement. All right, and just to get us started, what we are going to do is we're going to look at a little example. So, to get us started in this section, what we're going to do is we are going to let v of t be a velocity function, so that's going to equal velocity. And we're going to be looking at the velocity of some object or person between time 1 and time 2. Alright, so what we're going to be looking at is, well, how do I model the net displacement of a person who starts at one position and ends at another? So let's say that we're looking at the integral from t1 to t2 of somebody's velocity. What that's going to give us is that's going to give us their net displacement. So what we can think of is that if you have a person like this, whose legs don't connect well, well, imagine that they walked a distance and then turned around and walked back. And let's say this total distance is, let's say it's 4 meters. Okay? Well, if they walked this distance, let's say that they walked that distance 4 meters, so away from themselves, that's going to be a positive displacement. And then, when they turn around and walk back this direction, that's going to be a negative displacement, since they're losing distance when they're walking back towards themselves. So, if we were to draw a graph of this person's velocity, it would look something like this. Okay? And then the net displacement, well, we'd have the positive velocity, or I'm sorry, the positive displacement, the negative displacement, so it would equal 0. They'd end up just exactly where they started. Now, if we look at not the velocity function, but the absolute value of the velocity function, then what we are going to get is we are going to get their gross displacement. You can also think of this as a total distance. So now when we're looking at the same person, ooh, look at that, much better. So let's say that they went the same distance. Okay? Now, when we're looking at this, we're doing 4 meters, okay, this distance here, only we're doing the absolute value of both distances. Now what that looks like graphically is that we're going to take the negative distance and we're going to make it positive, which means that their distance would then equal positive 8. Yeah, so it's their total distance. Alright, cool. So let's look at an example of this. So for our example, let's say that we're looking at, I don't know, let's say that we're looking at my cat. So, for example, a cat's velocity let's say the cat's velocity can be measured by v of t, and it equals 20 minus 4t, and let's say that t is going to be measured in seconds, and let's say that v of t is measured in meters per second. Okay? So let's say that we want to answer this question. What is the cat's net displacement between 0 and 8 seconds? So what this is going to end up being is the integral from 0 to 8. We're going to have 20 minus 4t dt. So we can just evaluate this integral straight up. So it's going to be 20t minus That's going to be 4t squared divided by 2, which will give us 2t squared, and we need to evaluate that from 0 to 8. And when you carry that arithmetic through, you're going to get 32 meters. Now, what if I asked the same question, only instead of net, I ask about the gross displacement? Okay. Well, before I answer this question, what I'm going to do is I'm going to draw a graph first. So I'm going to draw the graph of the cat's velocity function. So let's see, it's negative 4t, which means it's going to have a negative slope. It's going to start at 20 and go down. Okay, so let's say that this is 8, this is 0, and right here, this x-intercept right here, you can find that by setting this equal to 0 and solving for t. So that's going to occur when x is 5. Now, here's the thing, is that this area below the x-axis, that area is negative. And the area above, which is right here, this area is positive. Now what we want to do is if we're trying to find the gross displacement of this cat, we want to take the integral from 0 to 8 of the absolute value of 20 minus 4t dt. What the absolute value means is that I want all of this negative area, I want that to flip up and I want that to become positive. So I want this to flip up here and then I want it to become positive. I want it to be positive, just like this side. Now what I'm going to do is that I'm going to use one of the properties that we learned in the past about integrals. And that property is that taking the area from 0 to 8 is the same as taking the area from 0 to 5, and then adding the area from 5 to 8. So this is going to be equal to, from 0 to 5, 20 minus 4t dt plus the area from 5 to 8, 20 minus 4 t dt. Now here's the thing, is that this area here from 5 to 8, well, it's negative. How do I make a negative into a positive? Well, to make a negative into a positive, what I'm going to do is that instead of adding this, what I'm going to do is I'm going to subtract. The reason is that a negative times a negative will make this area positive. So when you actually take the antiderivative of both and evaluate, what you're going to get is a total displacement